Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
This particular video is going to focus on what happens when you have a linear quadratic system. So keep in mind that we could have three different ways that a line and a parabola could meet. They could meet such that there's 2 points of intersection. When this happens, this is called a secant line because it meets in 2 spots. We could have it to where it just happens to meet in just 1 spot. This would be a tangent line. And you may or may not need to know those vocab words at this point in time. Or it might not meet at all. So this would be 2 solutions, 1 solution, and no solution. And the way that we're going to figure out whether it's 2 solutions, 1 solution, or no real solution is by utilizing the discriminant from the quadratic formula or something to that effect. There's other ways we could do it as well, complete the square, things like that. But remember, we're looking for our ordered pairs x and y since we're talking about the entire system. So our first example is going to be y equals x squared minus 7x plus 15 and 2x minus y equals 5. You could graph it and go ahead and find out whether you're in a 2 solutions, 1 solution, or no solution, but the big idea here is going to be able to utilize the algebra to solve this. So there's a couple ways I could approach this. I know several people would go ahead and get the y by itself in the second equation. So 2x equals y plus 5, and move the y over to the right side, subtract the 5, 2x minus 5 equals y. And that was the bottom equation. Since I isolated y in the bottom equation, I would have to take what it equals and substitute it into the top equation. So it would give us 2x minus 5 equals x squared minus 7x plus 15. This is quadratic because of x squared, so the best way to solve a quadratic is to make it equal 0. So 0 would equal x squared minus 9x plus 20. In this case, I can think of how to factor it very quickly. You could also go ahead and utilize the quadratic formula if you're comfortable with that. But because the a value is 1, factoring is often the fastest method. I know that 4 times 5 is 20. I also know that negative 4 times negative 5 is also 20. And since that's a negative 9, I'm going to use negative 4 and negative 5. So now, applying the zero product property, I'm going to set each quantity equal to 0 and solve. X equals 4 or x equals 5. That means we have the situation where we are crossing a new 2 locations. An ordered pair 4 comma something and an ordered pair 5 comma something. And it's our responsibility to get both ordered pairs. So to get the y, I'm going to do 2 times my x and then minus 5. So 2 times 4 is 8, minus 5 is 3. 2 times 5 is 10, minus 5 is 5. So there we go. We have 2 ordered pairs for our answer. Our next example has y equals written both times. So therefore it is ready for direct substitution. I'm going to go ahead and take this top equation and substitute it right there. So negative x squared plus 3x minus 5 equals negative x minus 1. Again, it's quadratic, so I'm going to set it equal to 0. So we'll have negative x squared plus 4x minus 4 equals 0. And I don't like working with the equations when my a value is negative 1. I prefer an a value to be positive 1. So I can either move everything to the right side, or I can multiply by -1, or I can divide by -1. I'm going to choose to multiply everything by -1. So positive x squared, negative 4x, positive 4, and 0 is both, like 0 is neutral, so it's neither positive nor negative. There we go. Again, this is a very easy to factor one. X minus 2 and x minus 2. It's that double root. We only have one unique solution for x, which means that this is where that was like a tangent line type idea, where it's just touching in one location. So that ordered pair, substitute 2, I'm going to utilize this. -2 minus 1, that's going to give me -3. So there's our only point of intersection. This example is written very similar to our first example. In the first example, I took y in the bottom equation and got it by itself, but some of you might have noticed that this y is already isolated. I can also do that. I can substitute that way. So be careful with this, that you know it's -1 times your y value. And I'm going to substitute what y equals into the bottom equation. So that -1 has to distribute through. Okay. And now I'm going to combine like terms. And make it equal 0. And again, I don't like a being negative, so I'm going to go ahead and make it positive by multiplying everything by -1. Okay, because the a value is not 1, it's not fast to factor, and it's not fast to complete the square, so I'm going to go ahead and quadratic formula this one. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. You might have heard me sing that in the quadratic formula practice. All right, so 4 times 2 is 8, 48, 25 minus 48. That'll be a -23. Okay, we have a negative discriminant, meaning drop off that negative, pull out the I. This is a complex radical, complex root. We're not going to be able to find where this parabola meets the line because it's in an imaginary location. It does not exist. These are not going to cross. So again, there are no intersections. So no solution. As well as having equations in a system with parabolas and lines, you might also have inequalities. You might remember from other videos of mine that whenever I see inequalities, I see turn signals, which means shading or coloring. Therefore, the graph is going to be our answer, so there's no way to avoid graphing these. The line is obviously going to be the one that is easier to graph first. So it is already written in slope-intercept form. So we're going to go ahead, and the y-intercept is +2. And the slope is -2. So we've got down 2, over 1, down 2, over 1, down 2, over 1. Reverse it. And because it's underlined, it'll be solid. So there's that solid line. Okay, it's pointing to the right, therefore it's a right turn signal. How do you get your right blinker to come on? You push up, so we would shade above or up greater than the line. And I'm doing it lightly as I have in previous videos because I need the overlapping color, not just the purple color. So now we need to go back and we need to remember how to graph this parabola. And this parabola is going to be a dotted parabola because it's not underlined. And it's going to be shaded under or left or less than. So under the parabola would be everything outside the parabola. So first thing we need to do is discover the axis of symmetry. That's at negative b over 2a, which just happens to be everything in the quadratic formula without the square root part. So that would be 2 over 2, which is 1. So 1 comma something is going to be our vertex. So we're going to make that table of values, and I'm going to put 1 as the center number. 1 minus 2 is negative 1, so that'd be negative 3. 0, that'd be negative 2. Negative 1 would be 1 plus 2 is 3. That would be 1. And then 2 would be negative 2 as well. And 3 would be 1 as well. So there's our 5 points to help us out. Negative 1, 1. 0, negative 2. 1, negative 3. 2, negative 2. And 3, 1. I have those ordered pairs plotted. And we would be shading below, which means down, 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 down. And what I noticed here is that the shading is actually overlapping in 2 separate sections. We have the shading overlapping below the parabola and above the line out here on the far right. And we have it above the line and below the parabola here. Kind of looks like a little angle symbol almost right there. So in this particular case, they happen to overlap in 2 separate areas, and that is okay. This is called unbounded because it doesn't stop. Had we had a problem like this, where the shading overlapped inside this middle, now we have boundaries on all sides. This would be a bounded graph. Unbounded because it doesn't stop, bounded because it does. Again, with these, the graph is your answer. And if you're struggling to graph either lines or parabolas, please go back to one of my videos specific to that item.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? Then drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.